Chapter 1.7, Transformations of Functions. So our goals are to use vertical and horizontal shifts, use reflections, and use non-rigid transformations, all to sketch graphs of functions. So if you remember this from Algebra 2, vertical and horizontal shifts. We're letting C be a positive real number. Vertical and horizontal shifts in the graph of y equals f of x are represented as follows. So the vertical shift, C units up, C units up is going to have a plus C at the end. C units down is going to be a minus C at the end of the function. Then horizontal. So horizontal C units to the right, so it's inside with the x. To the right is a minus C. C units to the left is a plus C in the inside with the x. So let's sketch these graphs. Sketch the graph of each function. We have g of x equals x cubed minus 1. So in this case, this is down 1. So down 1, and then if you remember the pattern, you can use the pattern, at least a minimum of 3. On tests and so forth, I will let you know how many minimum points you need to show. In this case, you can also plug in positive 1 if you're not sure how this graph looks like. Positive 1 is 1 cubed minus 1 is a 0. If you plug in 2, 2 cubed, or minus 1 cubed is a negative 1, and minus 1, which is a negative 2. So it makes this shape here. H of x times x plus 2 cubed plus 1. So this is going to be left 2, that positive 2 inside means left 2, and the positive 1 means up 1. So we move left 2, up 1, and then it's the same pattern. It's not stretched in any way. So it should be pretty fast. So try these 2 examples here, pause the video, and when you come back, I'll have the answers for you. So if you tried it out, letter C is up 5, and letter D is right 3 and up 2. So reflections in the coordinate axis. Reflections in the coordinate axis of the graph of y equals f of x are represented as follows. So reflection in the x-axis, you have a negative in front of the entire function. A reflection in the y-axis, you're going to have it only inside with the x. So let's do this example here. X squared and f of x equals negative x squared. So x squared, we know that's number 1, a parabola, and so it starts at the origin, and it goes up, right 1, up 1, right 1, up 3, and then you could do the same on the other side, reflect it. Now the negative x squared, so this is our x squared, negative x squared is just flipped over the x-axis. So you would still start at the origin, right 1, down 1, right 1, down 3. Okay, so that's a reflection in the x-axis. So let's try writing equations from graphs. Given the graph of f of x equals x to the 4th, write an equation for the functions represented by the graph in A. So here's a given graph of x to the 4th. So we need to take a look at this and see if we can figure out how is it transformed. So we know, number 1, that it's reflected over the x-axis. So reflected over the x, and then it's also up 2. So to represent that, we're going to say g of x equals negative x to the 4th plus 2. So see if you can go ahead and try B and C, write out the equations, pause the video, and when you come back, I'll have the answers for you. Okay, so letter B, you should have gotten negative in the front, x minus 3, right? It's right 3, so it's negative in the inside, and then raised to the 4th power, because it's reflected and right 3. Then this is also reflected, and now it's shifted left 3, so the negative in the front, parentheses x plus 3, all raised to the 4th power. Let's do reflections and shifts. Compare the graph of the function with the graph of f of x equals square root of x. So we have g of x equals negative square root of x. So hopefully this should be pretty fast for you. We know that if there's a negative in front, we know that g of x is a reflection in the x-axis. Is a reflection of f in the x-axis. Okay, so for this example, letter B, h of x, so notice that it's inside with the x, so h of x is a reflection of f in the y-axis. And then k of x, so k is a reflection in the x-axis and left 2. So go ahead and try these two examples down here. So if you try that out, letter A, it's a reflection in the x-axis of the graph of f. And then letter B, g of x is a reflection in the y-axis in the graph of f. So rigid transformations, the shape of the graph is unchanged. So we move it to the right, to the left, up, or down. It's a rigid transformation. The shape doesn't change. Now, non-rigid transformations, it's transformations that cause a distortion. It changes the shape of the original graph. So these are our vertical and horizontal stretches and shrinks. So let's do those very quickly. So compare the graph of each function with the graph of f of x equals absolute value of x. So remember, absolute value of x, the parent function is a v, right at 0, 0. And it has a slope of 1 to each side, or 1 and then negative 1. So h of x equals 3 times absolute value of x. So we know this is a vertical stretch. Okay, vertical stretch. And then 1/3 x is going to be a vertical shrink. So again, it's on the outside, right, in front of the entire function. Let's go ahead and go down to horizontal stretches and shrinks. So we have g of x equals f of 2 times x. So we see a 2. This is going to be a horizontal shrink. Horizontal shrink. And if you remember by last year, we would say by a half. But what we're going to do is go ahead and multiply this through, and so you can see it. So we're looking at 2 minus x cubed. And so if we plug in f of 2x, we're going to get 2 minus 2x to the third, which is 2 minus 8x cubed. If you can imagine this graph, you can see that it shrunk this way, right? Horizontal shrink. It goes more towards the x-axis, as opposed to the previous one would probably be more wide. Okay, so it's a horizontal shrink because it squeezes the graph, and so that's why it's a horizontal shrink. Let's look at the next example, f to the 1/2 x. So 1/2, that's going to be a horizontal stretch, so it's going to move away from the y-axis, making it wider. So if we plug it into this equation here, we have 2 minus 1/2 x to the third. So that's going to be 2 minus 1/8 x to the third. So 1/8, you see that's going to be very, very, very much stretched, right? And actually it's upside down. We know that it's up 2, and then it's upside down. So it's going to be very wide, as opposed to maybe the original would only look like this. Okay, so notice that the pink, it is stretched. That's why it's called a horizontal stretch. It stretches away from the x-axis. It makes more of a bowl shape. So if you would like, go ahead and try to do these examples here. So try g of x equals 4x squared. Just compare the graph. Describe the transformation of a up here and b, and then also do it for a and b down here. So if you try this out, you would see that this letter A, it's a vertical stretch, and so you're multiplying 4 to the entire function on the outside. And then the vertical shrink, you're multiplying 1/4 to the entire function on the outside. For here, letter A, this is a horizontal shrink, and so if you plugged it in, you would get 2x squared or 4x squared plus 3. This one is a horizontal stretch, so you plug it in 1/2, so it's going to make it a 1/4 x squared plus 3. Hope this helps out. Thanks for watching.